So next week is going to be Amali, right? Tuesday, Wednesday, Thursday. And physics comes first. I really hope that gives you a bit of confidence because hopefully physics is the easiest paper three. Fingers crossed, right? Straight away, some general guidelines first. Okay. Again, I think by now, most of you would roughly know what is very likely to come out from hearsay, right? So I'm going to prep you for that, right? But does it mean it's 100% true? Let's give it 99.9%, right? There's nothing that is 100%. So my advice is it's always great to study more than less, right? So don't just focus on one. You can put more emphasis on one, but who knows, okay? General guidelines first. You must make sure you read the question carefully because what they ask you to investigate will be very clear. Usually, the aim can be found in the question. The aim will contain manipulated variable and responding variable. If you can't find it in the question, then what you can do is you can take a look at the graph they want you to draw. Okay, the graph they want you to draw. From the graph, so you just flip the next few pages, you will see they'll ask you to draw a graph one. The graph y-axis is the responding one. Normally, x-axis is your manipulated variable, right? So if you can't get it from the question, you get it from the graph. It could be guided or unguided. Guided means you plan yourself. You write procedures yourself. Okay, I'll get to the procedure part if you are one of those people who are very afraid of procedures. Or it could be unguided. Sorry. Yeah, terbalik. My bad. Okay, it could be guided or unguided. Guided, that means they give you procedures and you do. Unguided, that means you plan and write procedures yourself. Sorry, this two terbalik. Okay. I feel this year more likely to be guided. I feel. Because last year already unguided. So this year, I feel very likely they'll give you some procedures to follow and you just go along with whatever they give you. But we don't know, okay? We can't be sure. To write your inference, you can always use this format. RV depends on the MV. Right? Use the word depends on. You don't terbalik, You use the logic lah. Who depend on who? You change the manipulated variable. The responding will depend on the manipulated. Okay? Or you can do this other version. But I think most teachers normally prefer this depends on one. Hypothesis simple. The greater, right? The greater the MV, the greater the RV, or the greater the smaller. Or as something increase, something decrease. Also can. Okay? Constant variable, you don't just write anything you want. Don't simply tembak any apparatus or what. It must usually be something that can potentially affect the results. Something that can affect the results. The best thing is if it is, it must. The best one is the one that can directly affect the results, right? You don't write something that is too general, too vague answers, like the size of the beaker and stuff like that. Some things, we need to make it constant, but it doesn't really affect the results, right? So don't go too general. And then procedures, 3 marks for these 3 steps. First step is how to fix your manipulated variable. Okay? How to fix your manipulated variable. So for example, if they ask you to fix the current of something, then you tell them, you adjust the rheostat to get a current value of whatever, right? And then how to get your RV. Let's say you are reading from the voltmeter. You just record the reading from the voltmeter. 1 mark, 2 mark edit. And then just repeat the entire experiment 4 more times with 4 other manipulated variable readings. So in total, you will have 5 readings. 5 readings in total. You can do more, but not less. Okay, you can do more or not less, but not less. Does inference depend? No. Okay, the inference is always just this format. RV depends on MV. Okay. Then you will have your results, which they will ask you to put in a table form. What is important is, number one, your decimal place must be consistent. Okay, so I give you some, for each row, I give you some examples here. Let's say you have some table only like that, only two column. Some will have more column, right? It depends lah, what are you looking for? You must put the symbol. Let's say like if I put current here, for example, then symbol will be I lah. Don't forget unit. Okay, you don't lose marks in all these small things lah. In physics, anything you write, got unit, you just put. Got unit, you always put. Okay, put the correct unit. And then let's say you want to get voltage. Then symbol is what? V. Unit also V. Okay? Oh, sorry, maybe not voltage, potential difference. We prefer this term. For example. Okay, so if everybody 1 decimal, then 1 decimal. Everybody 2 decimal, then 2 decimal. Including values like, let's say, okay, so for example, this is 2.79. This is 3.5. This is 4.2. You don't leave it as a blank. If behind got nothing to put, please put 0 to make sure the decimal place is consistent. Okay, so if everybody 2, then everyone must be 2 in the same row. Okay, if the same, not same row, same column. Sorry, my bad. I think this one got mistake. This is column, not row. Column, that means go down. Okay, column is go down like that. So same column, same decimal place. Okay, and you have 5. The table can be 3 to 5 marks. It depends. Okay, so sometimes they do like that lah. If they don't have too many questions to ask, then they will allocate more marks at the table, right? If they got a lot of questions to ask, then they will allocate less marks for the table and the graph. Okay, but it can go up to 5 marks. So the unit, the symbol, all this place is where they can minus mark. The decimal place also. Yeah. Then drawing the graph part. Again, must have unit. So if you are doing, say, current, then unit would be ampere. Must have the unit. Let's say if you are doing potential difference, then the unit is V, for example. Okay. And when you draw your best fit line, try to minimum pass by 2 points lah. At least 2 points. That's the least. Okay, that's the least. You can't just pass through 1 point. Unless you really feel like there is no other ways lah. But usually you can minimum pass through 2 points. Okay, so you must try to pass through as many points as possible. And then also you must balance the points. Balance, that means some will be maybe higher, some will be maybe lower, right? Don't have all the points all higher than the line. That is not balanced. So you try to draw a line in the middle, balance one. Okay, like this one is lower a little bit. This one is higher a bit. This one higher, and then got 2 on the line, for example. Okay, some below, some above, balance it. And don't always think it's going to be a straight line, because it could be a curve. It could be a curve. Let's be a bit ready for this year's question. If it really is a non-ohmic conductor question using a filament bulb, that is what everyone is saying will come out. We don't know. Then it would be a curve. Okay, non-ohmic, it would be a curve. So the curve also, you must try to pass through as many points as possible, and then try to balance off. Okay, try to balance off. Okay, the next part. They always will ask relationship. Okay, after you draw your graph, they always will ask relationship. So this year we put a little bit more emphasis on this. But like I said, be prepared for everything. State the relationship of your graph. Follow your graph, not the theoretical relationship in the textbook. Okay, let's say everyone is drawing a curve. Everyone is getting a curve. But according to your data, you get a perfect straight line. You write lah, perfect straight line, you get directly proportional. Okay, will it be correct? Correct, I'll give you a mark. Okay, your examiner just want to see whether or not you know how to look at your graph, and get the relationship. That's all. We don't care too much about your results actually. Okay, I know you guys are very worried about getting the value, the actual value, but do you think they actually care what value you got? Not really lah. Okay, not really. But your teacher can't be checking each apparatus set, right? So as long as the values look or seem quite logical, then it's fine. What if the graph is wrong? Okay, if the value is supposed to be give you a positive trend, and as long as you get a positive trend, then it's fine. Okay, unless it's supposed to be positive and your graph totally is the balik one, negative trend. That means something somewhere the whole experiment is wrong. But if you still can read the correct relationship based on your graph, you can tell them maybe decrease linearly or what. You're still going to get marks for the correct relationship. Okay. Okay, so if it's a straight line, then straight line. No? Okay, what if, let's say, I know in the state, your trials exam, some of you did Hooke's law, and maybe you can't get a directly proportional graph. You got this, maybe, huh? Then you say linearly, increase linearly. You don't say directly proportional, or you don't try to connect it to here like that. Okay? Follow your data. Follow your graph. Increase linearly, then increase linearly. Remember, theory and real experiment can be different one. No problem. Follow your graph. Huh? Your data like that, then like that. Okay? If cannot get pass through 0, then never mind. Don't pass through 0. It's fine. It's fine. Relationship directly proportional, but you write higher, can or not? Cannot. Okay? So normally for paper 2 question, when I say relationship, a lot of the time you will just say, oh, the higher the this, the higher the that, right? The greater, the greater. Okay? Normally can. But this comes from your graph. Graph, you must use the correct terms like this. Okay? You must say directly proportional or this. You can't use greater to explain graph relationship. When got graph, you must write like that. When you must write directly proportional or this. Okay, someone also asked, you're not sure how much time allocated. Yeah, I thought you have done a few rounds of the exam in school. You will have 5 minutes to check all your apparatus, 40 minutes to do the experiment, get your data and answer all the questions, including plotting your graph and all that. So you must do faster. Okay, you must do quite faster. But don't panic lah, huh? Okay lah, let's just quickly practice. If let's say you get a shape like this, then we say it is directly proportional. Straight line, positive gradient, pass through origin. If you get a graph that is higher, doesn't pass through 0, then we say increase linearly, or it could be decrease linearly, right? Follow your graph, follow your graph. And then what if it's a curve? Guys, I want to ask you, what does the word linear mean? Straight line. Hey, you get curve, you don't write linear, please. Okay, the word linear means straight line, but if you get curve, please don't write the word linear. The moment I get a curve graph, but then you write the word linear, confirm wrong. Okay, right? So you just say increase. Like if it goes up, then increase. Okay, so maybe it's going to look like a curve that is like this. This year, maybe you put a bit more emphasis on this. Okay, if decrease, that means maybe it is can be like this. It can be like this as long as it slopes down, or it can be like this. Actually, also can. Okay, But then last one, inversely proportional means that it is this. I think you all are quite good with inversely proportional. Okay, inversely proportional, the graph won't touch the axis one. Okay, the graph won't touch the axis one. Okay, so linear is for straight line. If it's not a straight line, don't say linear. Okay, don't say linear. Whoa. Someone asked, you don't know how much time you should spend. Oh. You don't know how much time you should spend to answer the questions. You only have 40 minutes to do everything, including getting your data, answer the question, draw the graph, get the relationship, and do everything. 15 marks. You only have 40 minutes to do that. Okay, right. Next one is getting the gradient from a straight line graph. That one we are used to it, or a tangent to the curve. Okay, later I will show you lah. Because we can only get gradient from a straight line. So for a curve like that, takkan I go and use dy dx, right? There's no dy dx in physics. So what we can do is maybe draw a tangent to the curve. Later I'll practice, I'll show you how to do it. But anytime you want to get gradient, you draw a triangle of minimum 4 big box, minimum 8 cm. This is a must. Or you just remember, you want to get gradient, you need to draw the triangle as big as possible, then can it. You try to do as big as possible, then can it. You don't have to memorize 8 cm or what. Okay. Next one, operational definition. A lot of people are quite worried about this. Usually you just have to relate it to your RV or what you get from the experiment. Okay. If what you get, I give you an example, is the period of oscillation. You know the experiment where you put a hacksaw and then you put a plasticine and then you just let it oscillate back and forth, right? The bigger the mass of the plasticine, then you will have a greater inertia. That means it will be slower, right? Bigger inertia means it will be slower. So inertia is your RV, right? Or liquid pressure is the difference between height of water column. If you're doing an experiment that involves a U-tube, let's say, right? And then there is something that will help you to, you press down and then there is a difference in water pressure and that stuff. And then you keep on measuring the height here. If that is your, whatever you are measuring, if that is your RV, then it is your operational definition as well. So it's just what you do. Okay, you're measuring the difference between the height, that is your liquid pressure. But for resistance, for voltage, for your non-ohmic experiment, very highly unlikely you will get a operational definition question. Okay, because the operational definition won't really make sense. Okay, so you don't have to worry too much. Okay, for non-ohmic conductor, there is no operational definition question. Okay, last part, the last 1 or 2 marks. Usually they will ask you, what will happen to the results or the gradient or something if I go and add something or I go and remove something, for example, right? If I add something else, what will happen? They will ask you. And your answer, you just have to say like that. Will it increase or will it decrease or will it stay unchanged? Sometimes they might ask you to explain further. But normally what happened, you just have to say the thing will increase or decrease or remain unchanged. Okay. You've got how to write. There isn't an operational definition question for this experiment. So there don't have, right? Don't have operational definition. So I can give you an example. Yeah. Okay, so I'm going to go to this non-ohmic conductor. This is an example question, right? Which is something you need to highlight a little bit more this year. Don't just study this lah. Be a good student, study everything else. Study ohmic conductor also. right? Just put more emphasis on this. A non-ohmic conductor, an example is a filament bulb. What makes something non-ohmic is when temperature cannot be controlled. Temperature cannot be controlled, then it will become non-ohmic. Like a bulb. Yeah, it heats up too quickly and it heats up to a very high temperature. Then it becomes non-ohmic. You can't control the temperature and therefore you can't control the resistance, right? So it will give you a value that might change a bit. Okay, ohmic conductor will give you a relationship that is like this. This is ohmic, right? An ohmic conductor, like a constant wire, for example, will give you this graph because temperature can be controlled, right? It won't heat up too much, and therefore the resistance will remain the same. Okay. So in your 5 minutes before before starting the whole experiment, they will give you 5 minutes. Please make sure you double check your apparatus if it really is this experiment. Double check if you have your dry cell holder, switch, connecting wire, ammeter, voltmeter, rheostat, and a bulb. Okay, just make sure you have all of it. Later I show you why you need so specifically 7 wires. Later we'll go and count, right? The aim to study relationship between current and potential difference of a filament bulb, or we can say of a non-ohmic conductor. Hypothesis, the higher the higher. Okay, hypothesis is the higher the higher. Can we write down the inference? Something depends on something. You're going to get potential difference. So your results, your potential difference across filament bulb depends on current flowing through it. And don't be too paranoid. You can add a few words, remove a few words. You'll still be fine as long as I see potential difference depends on current. Okay, you can change a few words. As long as it still means the same, it's fine. You can just write potential difference depends on current, or you can add a few words across the filament bulb, all that. Okay, no problem. Manipulated variable. We are going to, in this experiment, we're going to adjust the current. Okay, and when you write, you also put down the symbol if there is. Okay, if you know the symbol, you put it down. Responding variable, you're going to measure voltmeter reading, or you write potential difference. Yeah, for constant variable, you don't write temperature though. We already said cannot control for non-ohmic. The filament bulb is going to heat up until become very hot. It can be like 1,000 Kelvin, for example. Right? It'll be very hot inside the filament there. Instead, the best answer is the filament length, which is basically another way of saying type of filament bulb. You use the same bulb. You don't keep changing the bulb. Because a different length in the filament bulb would have a different resistance, and then you're going to get a different value altogether. Type of bulb. Type of bulb, maybe can, maybe not. This is even more specific, right? This is the one in the textbook. Okay, this is the one in the textbook. Number of dry cell use, yeah, that could potentially affect the constant variable. That could potentially affect the constant variable, but I would stick to filament length if I know about it. Okay, because this one confirm won't go wrong, is the one given in the textbook. Yeah, confirm won't go wrong. You can write other things lah, but if you want an answer from me, I would say filament length. Okay, but usually there will be a few acceptable constant variables on, right? Okay, procedures. We're going to draw a circuit first. Come. We do a battery. You see lah, got how many battery? But normally they won't count lah. If got two battery, you draw two lah. And then I draw a switch, let's say. Actually, right, you just need to make sure to connect everything in series first, except for the voltmeter. Okay, the order doesn't really matter. You can put the switch anywhere, you can put the ammeter anywhere, you can put the rheostat anywhere, it doesn't matter. You can put the bulb anywhere, it doesn't matter. The order does not matter. Okay, so don't stress about the order. The order doesn't really matter. One thing for sure, this is one continuous line. This is all in series. Everyone together, one continuous line is all in series. It never splits. The moment it splits, then it's parallel, right? So this is in series. And so when you go and do your experiment, you connect all of this first. The order doesn't matter. Bulb anywhere also can, rheostat anywhere also can, ammeter anywhere also can, switch anywhere also can. It doesn't matter. Right? Then the last part is you go and add a voltmeter in parallel to your bulb. Okay, normally resistor we will draw like this. But if it's a rheostat, you just add an arrow. The arrow go up, go down, point another way, also fine one. Don't have to worry. Okay, so if it's unguided, that means you have to plan yourself. Then you can say something like this. The circuit is set up as shown in the diagram. You just draw a simple circuit first. So just remember, everything's series, except for one guy, the voltmeter. Okay. Then you close the switch, because the switch is open, adjust the rheostat until the ammeter reading reads this. This is how you fix your MV. That is your first mark. Right? Do for one value first. You fix the first reading. The readings are example, by the way. Okay, it might not be this value. I'm following the textbook. Then record the voltmeter reading. Second mark. Okay, that is how you get your MV and RV. Last part. Repeat step 2. If you split it up into step 2 and step 3, then you say repeat step 2 and step 3. Okay? Because some of you say, can we do this as step 2, step 3, step 4? Can. Then you say repeat step 2 and step 3 then. Okay? So you see which are the steps you want to repeat. It could only be 1 step or 2 steps or 3 steps, doesn't matter. Repeat step 2 with 4 other different manipulated variable values. Okay, so if you want procedures, it is these 3 marks. The values are just example. If they ask you to do yourself, you can maybe follow this value. If it's guided, then you follow what they plan out for you. Okay, the values are just example. Okay. But I feel very likely it'll be a value that is values that are quite close to this. Okay, it'll be values that are quite close to this. I think they will use the same bulb as the one in the textbook if they actually ask you all to do this in Amali. Precautions. This is very classic one. Eyes must be perpendicular to the scale to avoid parallax error. Okay, scale of the ammeter, voltmeter to avoid parallax error. So if you want to read your skill, it just means that you need to read straight lah. You don't read it like that. You don't read it this way. If the skill is in front of you, you read directly in front of you, not from the side. Huh? Ensure connecting wires are connected tightly. Okay. When you connect to all the metal parts. Okay, you connect to all the metal parts, the conducting parts. You don't connect to a rubber part of the wire, for example. Okay, use logic a bit. And then turn off the switch after taking each reading to avoid filament bulb from becoming too hot. We can't control the temperature, but you don't keep on turning it on. If can. Don't turn it on for too long and then you do other things and then you just leave it there. It will become very hot. Okay. And then the resistance will become very high and then your value will be very high also. Okay. Can we go and quickly count how many wires we need? You see, you don't have to write lah, but I show you. Here we need one wire, this part. Then here we need two wires. And here you need 3 wires. Just want to show you why we need 7 wires. Here 4. Here 5. Then the voltmeter there, 6, 7. Okay, so in that 5 minutes in your preparation time, you count on, make sure you have your 7 wires, right? Or else later when you start your experiment, you panic. Okay, don't have enough wires. Okay, and then another thing is your wires can be red or black, right? Are they different? The red and black wire is the same. It's the same. You connect this way, that way, or you change red color wire, black color, it doesn't matter. It's the same. It's the same wire. How to connect the 4th and the 6th wire? Oh, okay. So you have a... Oh, later I got a diagram down there, by the way. Okay, later I have a diagram down here. You can connect it to the... Just remember, anything you want to connect, you must connect to a metal part. Okay, like if you want to connect to your crocodile clip here, your wires, just make sure you clip it to the metal parts, then you'll be fine. Okay, later we go through this diagram. Again, this one example only. But this is the values from the textbook. I feel if they want to ask you, they'll very likely ask you all these current values. Okay, maybe lah, maybe. But you'll see the highlighted one, no? Bolded and highlighted. Examiners actually don't care about your results. They don't care. They just want to see your experiment skills only. That's the purpose of paper 3. Actually, there isn't even a range. Okay. Maybe got lah, right? But just make sure that it's not too far from everyone's value lah, right? You do a few, you will roughly know the answer should be roughly where, right? And let's say lah, if you are the examiner, you mark, and then you just see, oh, all the value increase. Okay, it is roughly at the 0 point something, 0 point, everyone also 0 point something. And then suddenly got one guy, 10 point something, or 100 point something. Confirm that one I won't accept it, right? Not too far away, right? But they are not going to go to your table and go and test with your apparatus set one. So they won't know. As long as it's logical. Your teachers actually test with one set. Your teachers will need to try with one set, okay, and get their own results. So that would be like the benchmark lah. So everyone's value will be different. It's fine, right? Roughly there, Kennedy. But really, we don't care about the values so much. Really. Okay, as long as you see increase, right? Or increase. But you notice that this one, it increased in a pattern that is not consistent. This is just an example. Okay, not consistent. And when it's not consistent, it means that very likely you might get a curve. Okay, you might get a curve that look, you might get a value that look like that, right? And then when you want to plot the graph, and draw the graph of V against I, you just need to make sure your curve pass through as many points as possible. And also you can try and see to draw one time. And also balance. Okay, not very balanced. Let me try again. Graph use pencil, please. Okay, and I know here don't have any points, but you connect based on your knowledge, right? You know that it is definitely going to touch 0 if it's this experiment, because no current, no voltage, right now. So it's supposed to be 0, 1, no current, no voltage. Okay, so this is my version now. Right, I pass through a few points, and then some points a bit higher, some points a bit lower. Make sure start with 0. Don't shorten your scale. Okay, start from 0. Uniform scale, please. Okay, uniform scale. Label your axis with the correct symbols and unit. No symbol, no unit, you will lose marks. Okay, you plot your points carefully also, and try to draw your graph as big as possible. Okay, make graph as big as possible. Meaning, it can be landscape or portrait. Yeah. You can turn your graph paper, no problem. Okay, if you try to do a scale that maybe cannot fit, then you feel like if I turn the graph paper around, the graphs would look bigger and nicer. And then you turn your graph paper around, no problem. Can you memorize everything for exam? Not recommended. Because we don't know. I don't know if the current will be this. Okay, I don't know if the current, they will give you these values. So you be smart. If you ask me, of course, I say cannot, right? But you be smart with whatever you do. Make sure when you do the readings, your readings must be logical, okay? So according to my example, this one, the scale that I will use, you see, because all this is 0.02, 0.02, I might need to draw I might need to do landscape. Okay, because all this 0.02, I won't have enough space if I do it portrait. So I can turn my graph paper, and then here all this is so happen is 0.05, 0.05 difference. So maybe one big box, I do a 0.05. Okay. If I do like this on the x-axis, I would need about 11 big boxes, right? Normally you will have 12 big boxes here, and I think 9 or 10 or 8. I think 10 big boxes here. So you pandai lah, you see based on your skill, what would be a better thing. If portrait, landscape, but must start with 0 no matter what. Try to draw your graph as big as possible. Okay, so if it's a non-ohmic conductor, this is what we are expecting. But if really you get a straight line, okay, then you say straight line. Okay, if really your graph is like this, leave it. Then you say the relationship is directly proportional then. If really your graph is like this, then you say increase linearly. Correct. okay, the relationship will be correct as long as your points are plotted correctly, as long as your points are increasing and they look quite logical at one glance, then fine. Okay. Don't use a jump start. Do not shorten the scale of the graph. Always start the graph from 0. I'm not sure about other subjects, but must start from 0. And also, graph must extend to touch the axis. Okay, I know all of the values may be floating behind only. Okay, all of the values floating behind. You don't just draw a straight line or a curve that is behind, must touch the axis. X-axis, Y-axis, never mind, but must touch the axis. Okay, must draw until you touch. Could be 0, I don't know, it could be higher, lower, right? Depending on your knowledge. Okay, start from 0. I already say, careful, don't do a jump start. That means don't, some of you will draw like that if not enough space. Maybe in maths you do this, you do a squiggly line and straight away start from maybe 100, right? Suddenly from 0 jump to 100. That is a jump start. Don't do that. In physics, at least you don't need that. You must start from 0. Okay, let's go and answer some questions. Based on your graph, what is the relationship between V and I? Okay, if your graph really look like that, really look like that, then you say V increases with I. Please don't write linear. It is not linear, no. Linear means straight line, unless you really get straight line. But if it looks like that, then it's just increase. Based on your graph, how does the gradient change? Does it increase, decrease, or remain unchanged? Increase. If you don't know how to see, you can focus on the first section of the graph. It's quite flat. And then the back section is quite steep. The steeper it is, the higher the gradient value. Okay, the steeper it is, the higher the gradient value. So the gradient from very small value become greater and greater and greater and greater and greater. Gradient increases. Part 3, they are just asking for how does it change again. Okay, not really asking you to calculate the rate. How does the voltage change? Again, you say increase, decrease, or what? But you see, the increase of the voltage is not constant, right? If it's quite consistent, you're going to get a straight line. If it's like this, keep on getting bigger and bigger and bigger, the increment, this is an increase in the rate of change. Okay, so rate of change, right, actually is asking you again about the gradient. Yes. Every time the voltage, yes, it is increasing, but it is also getting bigger and bigger every time the increase, right? So if you get a flat line, then the rate of change is constant. The change is always consistent. Okay, this one is rate of change of voltage increases. What is the physical quantity represented by gradient of this graph? Don't forget, gradient means you take y2 minus y1 normally, right? Y-axis over x-axis. Then over x2 minus x1. What is on your y-axis? Voltage over current. Remember your V equals IR. Voltage over current is resistance. Yeah, gradient is always y value over x value. Y2. So you just look at your physical quantity that you're dealing with, voltage over or potential difference over current, that is resistance. I think they'll very likely ask you this Okay, they'll ask you how the gradient change, how what is your physical quantity represented by the gradient. I think that's a likely question. And they can ask you to read some values also. Very simple enough, right? They just ask you, based on your graph, determine the potential difference when the current is 0.05. Okay, this one example only. Let's say you found out 0.05 is here. You just draw a dotted line, just practice to draw a dotted line to the graph. And then like that. Okay, then that is how you show on your graph, meaning just draw dotted lines. Right, very common lah. You all do in maths and at maths a lot. Just read the graph. Whether or not you write the value here is okay, right? You don't write also fine, because they see the dotted line, they know you know how to read correctly, and then they will check your graph, not your friend's graph, and then they will ask you for the reading. So let's say the reading is 0.48. Make sure you have unit. Okay, example. Okay, you might think for a curve, they can't ask you for gradient. But what if they ask gradient of the curve at a particular current value? Please understand, the gradient at the point, all these points, keep on changing. Because it is not a straight line. A curve keep on changing. That's why in maths, you all learn dy dx. You can sub in different x values, and they'll give you different gradient value, right? They're all very different. But I want only at 0.18. So what do you do? Remember, gradient is the same thing as resistance. So if they say resistance is the same, so you look for 0.18. Let's say it is here. And what you do is you draw a tangent line. You want to find the gradient at that particular point, no problem. You can draw a tangent line. Draw as big as possible. Okay, for example, like that. You draw tangent line, tangent must touch only one point. You try to balance the spacing here and the spacing here. Make sure that agak-agak lah, right? But as long as I see it looks like a nice tangent, then okay. Not too slanted. Then to get the gradient, you do the usual draw triangle stuff. Okay, you read out what is the value here. You're going to use these two coordinates. So different points will have a different looking triangle. Okay, different points will have a different looking triangle. So let's not forget, when you draw your triangle, draw as big as possible. Draw triangle as big as possible. Okay, minimum 8 cm lah. Minimum 8 big box. But you draw as big as possible, you won't make this mistake already lah, right? Just draw as big as possible. What about if it's higher up here? Let's say 0.18 is higher up there, right? We don't know. Then we try to draw again. Yeah, you adjust your ruler lah. You see, if you put your ruler like that, this is not a good tangent. You will cut through 2 points or more. Okay, so you adjust, it'll be quite steep. And memang we expect the higher the graph, the steeper it is. The triangle can be solid line, dotted line, no problem. But you must have the triangle. Okay. Then again, you read your two values. These would be your, whoever is x1, y1, x2, y2, doesn't matter who is who. Okay. But you use 2 points that are quite nice. Okay, let's say you don't get a curve, you get a straight line instead. Okay, when you get the gradient, guys, try not to use the points that you already, try not to use the points from the table. Okay, try not to use the points from the table. Use some other points from the graph. Use some nice points from the graph. Because you might use a point that is not nice, like this one or this one. Okay. Remember, I'm looking for gradient of the line, the best fit line. At that point, you can kind of ignore all your points already. We don't really care about the points after the best fit line is drawn, right? We call it best fit for a reason. It is the best fitting line for all of the points, the one that best represents everyone. Okay. All right. And then got unit one. Don't forget gradient got unit one. What's the units for this gradient? Ohm. OHM. Because it's resistance, right? So your gradient unit is ohm. Okay. Can you take the so on top will be voltage let's say. At the bottom will be ampere right? Because y-axis is voltage, x-axis is ampere, the units. If you put VA -1, can or not? Can also. You can follow your axis. Can, as long as it's a logical unit, a correct unit. Ohm also correct. Ohm and VA -1 is the same. Can. Okay. There might be a possibility. I don't think it's a high possibility though, a low possibility, that maybe they might throw to you a milliammeter instead of an ammeter. I give you a milliammeter, for example. The unit will be on top of the ammeter. You don't have to worry. You just look at the ammeter. Oh, ampere, then ampere. Milliampere, then follow milliampere. Okay. Voltmeter, you see voltage, then voltage. If you see millivolt, then millivolt. Right? It will be on your apparatus. Okay. So if milliampere, then it's V, and then you put milli. If you write like that, can or not? Can. If you write like this, can or not? Can. You can put a bracket. Let's say if you're paranoid, because the whole thing is below it. You write like that, can or not? Can. We can't say it's wrong. It is correct. Example I'm just giving you different possibilities. Who knows? Milliampere, if they want to play with you. Must have unit. Anything you can write unit, you just write. Okay. How does the resistance change when the current increase? As the current increase, the gradient also increase. So based on our this particular graph, resistance increases. Okay, this one just to show you the explanation why resistance increase with increasing current flow. There's something to do with the temperature, because temperature will increase when you have more and more current flowing through. And when temperature increase, the resistance will increase. Okay, so this is in a situation like for a filament bulb, temperature cannot be kept constant. We say the tungsten coil inside as the filament will exhibit non-ohmic characteristics. Possible. Light bulb that is not hot. Possible. Some bulbs don't use filament. Maybe a LED. LED. Okay. Number 9, define Ohm's law. They won't ask you this but if if you want to know, let's just go through what is ohmic, what is not ohmic, right? Ohm's law is just saying potential difference directly proportional to current. Okay, that is what Ohm's law says, right? And Ohm's law is saying that the graph supposed to look like this, directly proportional. Okay, that is what Ohm's law says. But in a situation where when temperature cannot be controlled, then like in question 10, based on your graph, is Ohm's law obeyed? No, Ohm's law is not obeyed. They ask to explain, you just say, because it doesn't look like that. You just say V is not directly proportional to I. Again, all this is referring to this curve graph. If it's this curve graph, I think you can star number 11 and 12. Remember I say just now, the very last part, they might ask you some theoretical question. What if I go and add a few more filament bulbs in series, okay? Or a few more filament bulbs in parallel? What will happen to the ammeter or voltmeter reading? And then explain. More bulbs in series. Will the resistance increase or decrease? Resistance go up. Okay. Remember the formula is R plus R1 plus R2 plus R3. But if you put in parallel, then overall resistance will go down. Because the formula is 1 over R, it behaves the opposite way. It's 1 over, behaves the opposite way. So we got our answer ready. You just have to use this to explain, or to use this to get your answer. Don't need. Okay, so our answer would be, when R goes up, you tell them V is going to go up, and you tell them I is going to go down. Okay, so ammeter reading, I think they will ask voltmeter reading, because voltmeter is your responding. Ammeter reading decreases. Voltmeter reading increases. What is the reason? If they ask to explain, you say, because effective resistance, total resistance increases. That is the reason why the reading changed. Okay, and then when R go down, you refer to the formula, R and V, they are both on top. So go up, then also go up. Go down, then also go down, the V and R. But R and I, one on top, one at the bottom. So they react opposite way. So we all know the reason for this is effective resistance. Effective resistance means the total resistance decreases. The more bulbs you add in parallel, the overall resistance is going to drop. Ammeter reading. Don't need to memorize. Use the formula to help you to get. Okay, so they can ask 2 marks, ask voltmeter reading maybe, and ask you to explain, right? If they ask what happened, normally just say, oh, it will increase, it will decrease, or it will remain unchanged. Oh, another way they can ask you this. What happened to the gradient of the graph? Okay, what happens to the gradient of the graph if you add in series? Okay, resistance go up. Remember, resistance represents the gradient. So it also means that gradient increases. Just say like that. Okay, what happens to the gradient? You say gradient will increase. They just want to test you and see whether you know the gradient is resistance, or the gradient decreases. Or maybe I write here, gradient go down, gradient go up. If they ask gradient, they can also ask gradient. Okay, last two questions. What is the purpose of a rheostat to control current flow? Right, you don't have to worry. You just slide. If you slide this side, the current become bigger. Then you slide the other side to get smaller current. No, let's say if you, right, the one just trial and error lah. You can only slide left and right lah, right? So don't worry about that too much. How to obtain a straight line? You use an ohmic conductor lah. Use something that you can control temperature one, like a constant wire. Okay. Please, you don't connect the ammeter, voltmeter wrongly. Ammeter must be series. Voltmeter must be parallel. Okay, so you just connect like how I teach you to draw just now. Connect everything in one straight line first, except for voltmeter. Series means one continuous line. Okay, you connect everything one continuous line. I know you can't really see, but this is actually the ammeter. Okay, let me use a more obvious. This is actually the ammeter. This is actually the voltmeter. You all know the red color and the black color thing on the ammeter and voltmeter or the battery here. You all know what color means positive or negative? I'm not talking about the red and black of the wire. Okay. Red means positive. Black means negative. Not for wire, for your voltmeter, your ammeter, battery holder, all those. And then it always works. Yeah, actually, you don't have to worry about this too much. Okay. You just have to make sure you connect everything except for the voltmeter first. Just connect. And then at last, you just click the voltmeter to your bulb. Okay, connect your voltmeter parallel to your bulb. Just make sure everyone is one continuous line first. Battery, connect to the switch, connect to ammeter, connect to bulb, connect to rheostat, come back. Make sure that is continuous first. Then later only you connect voltmeter to the bulb. Okay, but which terminal connect to which terminal? Let's try and see. So this is positive terminal of the battery. Switch don't matter one. Switch can be, you turn around also can one. It doesn't matter. Then it goes to the positive terminal of the ammeter. Then positive AD, you come out from negative, right? And then bulb also don't matter one. You turn around, the bulb is the same, right? The switch, you turn here, turn there, also same one. And then you go rheostat also actually same. Okay, rheostat actually also don't matter. Then end up you will come back to negative side again. Okay, you don't have to worry about this really. You connect it usually be correct one. If you're very paranoid, then you connect exactly like this diagram. If you're extremely paranoid, then you connect exactly as the diagram. They might give you a bulb like that. They might give you a bulb in a like a plastic plate thing, and then there's the bulb here, and then maybe it will look like an ammeter lah. There'll be something for you to clip on, right? Just make sure you always clip on the metal part. Anything you clip, you don't clip on plastic. You don't clip on rubber. You clip on metal parts. Yeah, use logic. Okay, the plus minus, not for the wire, right? A lot of your school ammeter will have this kind of reading one. Got 2 layers of reading one. Okay, it just is looking at the experiment you're doing. If it's very big values, up to 5 ampere, 4 ampere, then we will use the top row. Okay, if you are doing up to 1 ampere only, for example, the experiment values I gave you all, then you all would just clip it to this guy, the 1 ampere part. Okay, if you clip it to the 1 ampere one, that means you are using this scale. Ignore the top row. If the ampere is like 1 point something, 2 point something, 3 point something, then you clip to the other guy lah. Okay, some ammeter got this two scale like that. Okay, see if your current is big or small. Okay, and so assuming your current is very small, okay, the middle here would be your 0.1 ampere. And then if you don't know what is one small scale, you just divide lah by 5. Okay, take 0.1 divide by 5, then you will know each gap is 0.01, right? So actually the next one will be 0.12. Then the following one, 0.14, for example. Okay, maybe that's the reason why the textbook example values are like that. So the difference is so small. When you do you must really read carefully, you know. You must make sure the mirror is used to avoid parallax error. Okay, so let me explain this mirror a bit. This is the mirror, by the way. Okay, by right, there shouldn't be a second image. You see this one got an extra line here. If you read it from directly straight down perpendicular to the scale, you're not going to get that. You are only going to get this second image if you read it slanted. Okay, that one common sense, like you don't read saying like that, or you don't read saying like that. Okay, it must overlap. The needle and the needle and the reflection and the mirror image must overlap. Oh, then they. Hi, sorry guys, my laptop died. All of a sudden, I don't know what happened. Okay, so sorry. Back to here. Yeah, the needle. I was saying the needle and the mirror image must overlap. Must overlap. But again, it's not something you have to worry about, because if you read like how you normally would, no problem. You don't read it saying it like that, then okay. Okay. But it's very important because you know you are reading values that change so little. So that very slight difference could be quite big. Okay. If they give you milliammeter, then here they will write very obvious one. It will be MA, that one. Okay, then you just read MA. Okay, if it's milliammeter. And then what else that you need to know? Oh yeah, the scale. So your reading, right? The smallest reading is 0.1. Okay, but let's say if your needle land at the middle, say like right here. Okay, it's between 1.1 and 1.2. Then you read a 1.15. Okay, 1.15. So I think if you get the exact same voltmeter, you can do everybody 2 decimal place. Right? Because it could be in the middle. Then you do a 0.05. But you can only read in the middle. You can't read like, oh, I think it's 1.13 like that, or 1.17 like that. Okay, you decide. You can only cut the smaller scale by half. Right? Middle then middle, to the left then to the left, to the right then to the right. You see which one closer. Okay, so that's why I can read this reading up to 2 decimal. The smallest reading I can cut by half. So it can be a 0.05. Okay, but if so happen all of your one land on the same line, then one decimal, it's fine. Then everyone in the table consistent one decimal. If two, then everyone two. Okay, if you get 1.3, then you write 1.30 to stay consistent. Huh? Okay, I think last one, rheostat out is here, in is here. Just don't connect it to the, one side must be here, one side must be here. Okay, just don't connect both at the same front part. Because the current is going to go in, pass through the coil of wire, and then it will go out and then come out. Right? That's why you go and slide it. So if you put your slider here, then it will pass through less coil wire, and then it will go up, and then it will, that for example. Okay. And don't connect your battery wrong lah. This one, got people connect the battery wrong 2 years ago. Because 2 years ago, the experiment was finding EMF. Don't so mean lah. Okay. The spring part is the flat part of your battery. Okay. The pointy part, you don't connect it to the spring lah. Okay. Sometimes the battery holder, they would flip one, the spring one side here, one side here, one side here, one side here. Sometimes the spring all at the same side. You pandai lah, you don't connect the wrong one. And also, they might give you 4 battery. You use all 4 and you connect to this and this. They might give you 2 battery only. Then you connect to this, right? You just put 2 battery and then you connect this two. So this one can be different number of batteries. Don't say, oh teacher, I must use 4 battery. Never mind, it can be 1 battery, 2 battery, 3 or 4, right? I don't know what your school one looks like. I think it looks something like that. Okay. I think that's all. Okay. If you got any questions, you can ask me, or else good luck. Okay. Just focus a little bit more on this, but I think this will come out filament bulb. But who knows? Just be prepared, and don't be so rigid right? Question can change a bit. Be flexible with it. You know, you can ask for help. If all your apparatus cannot get values, then you faster ask for help lah. If in 20 minutes you still cannot get anything, you faster ask for help already. Okay, the examiner might minus 1 or 2 marks, but at least you can get reading and plot graph and get relationship and answer the questions rather than not getting anything, right? 1 or 2 mark lah. You don't left 5 minutes only and then you give in and you ask for help. If 20 minutes you still cannot get anything, you faster ask for help already. Okay, you can ask for help. They might minus 1 or 2 mark, right? But I feel that is better than getting no readings. Why cannot connect if you use 2 battery? If you use 2 battery, because this side plus right? Then this side minus lah. So the battery link one right now, it goes in. If you use 1 battery and 2 battery, then connect, and then it will come out like this. Right? Yeah, yeah, correct. Each terminal here is connected to each battery holder one. Okay. If 1 battery, then 1, 2 battery, then 2. Okay, a lot of things is very logical and you just don't panic. Just chill, connect all in series, check your apparatus or then connect your voltmeter. Then you just start to slide and read your reading. You'll be fine. Okay. All right. We'll take a break.